0.22 molar sodium fluoride solution at 25 Celsius. Now the Ka of HF is 6.8 times 10 to the power negative 4. Before we proceed into solving this question, I just want to have an idea about the answer that I'm going to get, whether NaF is acidic, basic, or neutral. Now we know that Na is pH neutral and F minus is basic. So basically this salt is going to be basic. So my expectations is to have a pH higher than 7. Now, basic. Now since here the given is Ka and I know that I'm going to have a basic solution, I'm going to first proceed and calculate the Kb by using the formula Ka times Kb equal Kw. Therefore, Kb is going to be equal to Kw over Ka, which is 1.0 times 10 to the power negative 14, because we have it at 25 Celsius, over the given Ka, 6.8 times 10 to the power negative 4. And therefore, the answer is 1.47 times 10 to the power negative 11. Since we already know that NaF is a basic salt, Na plus cannot hydrolyze with water, meaning it cannot react with water. But F minus can. So here, F minus can react with water. So I'm going to write the hydrolysis reaction of F minus. F minus is going to act as a proton acceptor. It will take an H plus from H2O, forming HF and hydroxide ion. And now I'm going to use the ICE table. So F minus given here, 0.22 molar is the concentration of NaF, which is equal to the concentration of Na plus, and also the concentration of F minus would be 0.22 molar. Nothing here, minus x, that's the change, plus x and plus x, 0.22 minus x, x, and x. Now, because we have a base, we are going to use the formula of Kb. Now, Kb is equal to OH minus multiplied by HF over F minus. And that is equal to 1.47 times 10 to the power negative 11. Now let's substitute. This one is equal to x squared over 0.22 minus x. Now that's the formula that we are going to work on it. Now, is there something we can do about this x? I can take the original concentration and divide it over the value of Kb. By plugging this into my calculator, I'm going to get a very large number, which is much larger than 500. Therefore, we can ignore the x in here. Therefore, I'm going to write the equation again. 1.47 times 10 to the power negative 11 equals to x squared over 0.22. Like I said, we ignored this x. Now, plugging this into our calculator, x, which is the concentration of OH minus, will be equal to square root of 1.47 times 10 to the power negative 11 times 0.22, and that is equal to 1.798 times 10 to the power negative 6 molar. So that's the concentration of OH minus. POH is minus log this value, which is equal to 5.74. And therefore pH is 14 minus the POH. So it is 14 minus 5 and the pH is 8.25, just like how we expected it to be.